Hello friends, get ready to learn a very interesting topic known as force and torque on a dipole in non-uniform electric field. This means that note down the field is non-uniform. This is a very important topic, many times come in many competitive examination. So you have to understand this very carefully. So in this situation, the electric field is not uniform. Let us here electric field, here the electric field, let the electric field is E1 here and here it is E2. So these two electric fields are non-uniform. In this electric field, we are placing here minus Q charge and we are placing here plus Q charge. Then what is happen? This will create when plus charge is here and minus charge is here. Plus and minus will produce electric field. So these electric fields are not uniform. These are not uniform electric field. So you are saying that electric fields are not in equidistance, so they are not uniform. So this minus charge will attract towards this. Let the electric field at this point is E1. You said this is let the electric field is E1. And electric field at this point is said to be E2 because they are not uniform. So I am writing E1 and E2. And this is here it is E net electric field. Okay. Then this electric field E1 produces a force. This will move this side. So this is force F1 equals to minus Q into E1. And this will move this side. This is force F2 equals to Q into E2. So number A, net force F net is equals to F1 plus F2. So what is F1? F1 equals to minus Q into E1 and this is equals to plus Q into E2. Take out the Q common, you have minus E1 plus E2 which is in vector form. So this is not zero. This means that the force on the charges placed in electric field which is not uniform, then the net force is not zero. What about the torque? Torque tau is equals to P E sin theta. So torque tau is equals to P E sin theta. Here P will be also created and net electric field will be also created. So P will be there and net electric field will be also there. This means that torque is also not zero. This means that torque is also not zero. So when a dipole is placed in a non-uniform electric field, then the dipole will experiences a force also and a torque also. Now we have some situations to understand in this case. So here you have case 1, that is P dipole is perpendicular on electric field, resultant electric field perpendicular. Then what will be happen? So when you draw this dipole which is perpendicular here, this is perpendicular minus Q. Then again you are saying the same thing that the forces are acting here, two forces. So again you are saying that force F net is equals to minus Q E1 plus Q E2 which is not equals to 0 because E1 not equal to 0. And in this situation the angle between net electric field and torque is 90 degree. So in this situation also you have torque which is PE net sine 90 degree which is P net which is not equal to 0. This means that when the dipole is placed perpendicular in a non-uniform electric field, then both force and torque will be produced there. Now what will happen when P dipole moment is parallel to electric field net? This means that we have to keep this parallel. Then what will happen? Let this is P dipole moment parallel. So you have minus Q charge here, you have plus Q charge here. Here electric field is E1, here electric field is E2. Then this will move this side. This is F1 equals to minus Q E1 and here F2 equals to plus Q into E2. Again when you add the force you have minus Q E1 you have plus q E1, so they sum up and not equal to 0. Here we need to solve it further also. We can write like this. This is minus q. E1 can be written in the form of p cap. So this direction and this direction are opposite. So you will write here E1 minus p cap plus q E2. Direction of E2 and p is same. So you write here p cap. So minus plus. So you have q E1 plus E2 p cap. So you are seeing that the force acting is towards the direction of dipole moment. So force F net is towards dipole moment, or you can say that the force F is along the increasing direction of electric field. Or you can say that force F is along increasing direction of electric field. Now let us work out for torque. Number B part. Torque tau is equals to P E sine 0 degree. Sine 0 is 0, so torque is equal to 0. So here you have seen that there is net force, and the force is advancing along the direction of increasing electric field, but torque acting on it is 0. Let us have the third case. In this third case, these are taking anti-parallel. So for anti-parallel, we required plus here and we required minus here. So the dipole moment will be moved this direction, twisted direction. So now here, this plus this is the plus charge here. So plus charge and plus charge repel. So this is the direction for F1, and this is minus and minus repel. So this is the direction of F2. So this direction and electric field E direction, E net directions are same. So this means that you have taken plus here, and this F2, here F2 is in this direction towards negative x-axis, and electric field towards positive x-axis. So this become negative here. So now F net equals to plus q E1 minus q E2. So again it come to be non-zero. Now write it in the form of dipole moment. So when you write it in the form of dipole moment, then what will be happen? This is q. What is E1? E1 direction, so direction of E1, and this is P is opposite. So you write minus P cap. So you have minus here also. And direction of E2. See the direction of, what is direction of E2? Direction of E2 here, and direction of P is same. So you write here P cap. So from here you have minus q E1 plus E2 P cap. This means that net force is towards decreasing direction of electric field, or net force is opposite to the direction of dipole moment. So net force is opposite to the direction of dipole moment, or you can say that net force is towards decreasing direction of electric field, or you can say that net force is towards decreasing direction of electric field. Now you have to learn part B. What about torque? Torque tau equals to P is sine 180 degree. Again sine 180 is 0. So this is equals to P into 0 is equal to 0. So when the dipole is placed in non-uniform electric field, either parallel or anti-parallel, in the both situation, net force will be created but torque will be not created. So torque is 0, net force is not 0. But when the dipole is placed in non-uniform electric field in any another direction, arbitrary angle, then you have both net force and net torque. and when it is placed perpendicular, then you have net force and maximum torque. Thus you have learned what will happen when dipole is placed in non-uniform electric field. So do like, share and subscribe my channel.